Hi students, good evening to all of you. Let me know how was your paper today. I think the CBSE students have appeared for their English paper today, isn't it? So if you can just send in your comments on how was your paper. Okay, hi Vaibhav, how are you doing? Good to see you on the platform. Okay, so guys, today's session is going to be on the second part of your Newton's law. Right, yesterday we did questions on your springs. That is, we took up the area which was actually a pain area. Students have written to me on the Telegram, and yesterday also I got a lot of messages from the students after they have seen the session, and they said that, sir, let's do your constraint relations. Right, constraint relations, we have the questions of constraint relations in different formats. Right now, three most important areas of the constraint relations that I'll be discussing with you students today. They are, number one, we have the string constraint relations, then we have the pulley constraints, and finally we have the wedge constraints. Right, so without any delay, let's just move ahead with today's session. Okay, so guys who are coming to this platform and the YouTube channel and seeing our lecture for the first time, let me introduce to you myself. My name is Sumit Kundu. I am a BTech graduate from IIT Bombay in civil engineering. All right, and my rank was, you can see here, 2125. I passed out in the year 2007, and since then it's been a long journey. It's been almost 10 years now that initially I was into the corporate sector, and also had my own startup, okay, which I'll later tell you in some of my plus classes maybe, okay, which was later acquired by Naukri.com. And it has been 10 years that I have been teaching physics for various competitive examinations, whether you call it your JEE, NEET, and JEE Mains, Advanced, and all those. Okay, so guys, let's start our today's session. Okay, now before starting, we want to tell you there are a few important things which you must remember. If you have missed out on any of the lectures by your Unacademy, okay, this is where you must visit tinyurl.com/JEE mobile. Okay, it's an archive of all the video lectures that was given to you by the best educators of the country. So here you will find all of these lectures. Okay, then we have the Unacademy subscription. Do not forget to use the code SMLIVE in order to get a right away 10% discount. Okay, and guys, here we have our first question. Now, students, those who have been solving all the pulley block related problems, okay, I would want to optimize your time in the examination as much as possible. This is a very simple question, right? But students, they still tend to solve it by a elaborate method. Okay, what they tend to do is, like, let's say I have got a 10 kg block out here. Let me get my pen first. Okay, just a second. All right, so here we have it. Say there is a 10 kg block out here, and we have a 20 kg block. Right, students? We've got two blocks, and in between there is a spring balance. All right, we want to find out what will be the reading out here in the spring balance. Clear? Now this actually measures what will be the tension, right? It measures what will be the tension in the strings, and that will be your answer. Right, now generally students, what they tend to do is they will write down an equation for this, they'll write down an equation for this separately, okay, and go ahead and find out, like, you know, what will be the tension. Rather, one short formula will be very useful for you students. Simple thing. Okay, what is the short formula? That is the acceleration of the system. See, one thing is very clear, that with whatever acceleration this block is going to go down, with the same acceleration, this block is going to move in the upward direction, right? So this acceleration is equal to the unbalanced unbalanced load, excuse me, it is, let me just rub off this part. Okay, let me just rub off this part, and we can have it, let's say, out here. Okay, so note down, this will really make your life a little simple. Unbalanced load out here. Here I have 20 kg, here I have 10 kg. So the unbalanced load will be equal to how much? Will be 20g minus 10g divided by the total mass of the system. The total mass of the system is 10 plus 20. That is equal to 30 kg, isn't it? So this will be 30. So I can write this as g divided by 3 as the acceleration of the entire system. Now, finding out the tension in this case will be very simple for me. Okay, how do we find out the tension? It's very simple. See, we can take any one of these blocks. Let me take this block. Tension out here is T. We know it is going down with an acceleration of g divided by 3, and there is another force acting on it, that is 20g. So here I can find out that is my 20g minus T will be equals to 20 into 10 divided by 3. Simple equation. Okay, now idea is tension will be equals to 200 minus, this is going to be how much? 200 divided by 3. If you solve it, you will get 400 divided by 3 Newton. That will be nothing but 600 minus 200, that will be 400 divided by 3. That will be your answer. Okay, that is the tension in this ring, and that will be equal to your reading of this spring balance. Ultimately, what I want to tell you is, do not write too many equations, just need to follow this particular formula. It really saves time in the examination. Okay, chalo, now let's move ahead to the next question to elaborate a little more on the usage of this particular formula. Okay, now see, you have got 3 blocks, right? This is a 2 kg block. This is a 3 kg block. We are going to come down to multiple choice questions. Okay, I'm going to open it within a short time, and this is your 1 kg block. All right, so what will be the acceleration of each of these blocks? First of all, do you agree to the fact that all of them are going to have the same acceleration? Right now, if you tend to solve this question, generally what do students do is, we know that there is a tension T1, there is tension T1, here there is going to be tension T2, here there is going to be tension T2, and they will write down equations for all the 3 blocks. They'll write down equations for all the 3 blocks and keep solving those equations, and like, you know, lot of time gets wasted in the examination. Okay? Instead of that, let's do one thing. Let's simply do one thing. Find out the acceleration of the entire system using the formula unbalanced load divided by the total mass of the system. So what will we get? Acceleration will be unbalanced load. See, this is not contributing to the unbalanced load. I've got 2 kg here and I've got 1 kg out here. So it will be simply 2g minus 1g divided by the total mass of the system. The total mass of the system. What is the total mass of the system? 2 plus 3 plus 1. 2 plus 3 plus 1 is how much? 6 kg. So this is going to be 6. So this is going to be g divided by 6 meters per second square. That will be the acceleration. Fine enough. Now, once you get the acceleration, you can easily calculate what is your tension T1. You can also calculate what is your tension T2, and your solving time is going to reduce tremendously. All right. By the way, I'll not go ahead and calculate your tension T1 and T2 out here. That is pretty simple. You can easily do it. Okay. Now, this was one of the things that I wanted to convey to you, because this requires a lot of effort from your end to solve everything. So in order to decrease the effort, you remember the formula: acceleration is equals to unbalanced load divided by the total mass. Fine. So guys, now let's move ahead to the constraint relations. Okay? What do we have here? The first question. In the first question, I'm going to tell you the solution to this particular question, solve the next one also, and the third one is homework. You test it for yourself. I'm going to give you 2 minutes and I want the answers in the chat box itself. Test yourself if you have understood the method thoroughly. Okay, if you have understood it. Okay, now let's move ahead with this. See, simple idea. There are like two blocks, block A, block B. Block A, block B. Block A is moving in this direction with a speed of how much? 5 meters per second, right? It is moving in this direction with 5 meters per second. What should be the velocity of block B? Simple idea, right? Now, see that if block A is moving in this direction with 5 meters per second, then this point here, this point, this point, this point, this point, all are moving in the same direction with 5 meters per second. It is clear. Then this point, this point, this point, all of these points will also move with 5 meters per second, right? Similarly, I can say this point here will also be moving in this direction with 5, just a second, with 5 meters per second. Clear? Then simply what you need to do is, if let's say this is the velocity of block B, then a component of this velocity in this direction should be equal to 5 meter per second. Simple idea. Now there is usually a confusion among the students that should I take component of 5 along this direction or component of VB in this direction. Remember, for all questions on this kind of constraint relations, okay, you will take the velocity of the block or the ring or whatever and their components along the direction of the string. Always their component should be taken along the length of the string. Very simple idea. Okay, so here this VB cos 53 degrees should be equal to 5. Now what is your cos 53? It is 3 divided by 5, should be equals to 5, which implies your VB should be 5 into 5 divided by 3, that will be equal to 25 divided by 3, okay, meters per second. I hope everybody gets this particular question, okay, gets the logic or the concept. If you have understood it, do not forget to press on the like button right away, students, okay. Go ahead and press the like button if you have understood this particular question out here. Now, want to look at a similar question, right? Chalo, let's have a look at this particular one. Now, something very similar, something very similar. See, this is a ring out here. It can only slide horizontally. It is moving over a pulley which is kind of fixed. It is connected to another block A. Now, this block A is moving down. It's moving down with a velocity of 2 meters per second. Then what should be the velocity of this particular ring? That is the question. Very simple, right? Once you have understood the constraint relation for strings, see, simple idea, a string, okay, at every point it is neither going to compress, neither going to elongate. So velocity of every point on the string must be the same. That is the only idea out here. Okay, so if this is going down, by the way, is some of you are answering this particular question, 5 by 2, yes, it is the right answer. Who is it who gave me the right answer out here? Adil, awesome. You've done a very good job. Okay, chalo, let's see. This block is going down with an acceleration of 2 meters per second. That means this point, okay, this point, all the points are moving down with the same velocity, that is 2 meters per second. Clear? Acha. Now this point and this point also will be moving in this direction with 2 meters per second. Let's say the velocity of this is V. So we are going to take the component of the ring along the direction of the string, right? And not take the component of this velocity along the direction of the ring. Remember this. always the component of velocity of the ring or the block along the direction of the string. That must be remembered. Fine. Once you remember this, we have very simple question out here. V cos 37 degree is equal to 2, which implies V cos 37 is 4 divided by 5 is equal to 2, which implies V will be equal to 10 divided by 4. I can write it as 5 by 2 meters per second. Alright guys, if you have understood this, do not forget to press the like button and share and subscribe so that somebody else also might learn this particular concept. Alright, chalo guys, let's move ahead, and the third question is your homework. Alright, it's your homework. Let's have a look at this. I'll keep it as your homework. Oh, by the way, why homework? Why not you people do it right now? Chalo, let's see. Let's have a look at this particular question. I'm going to give you 1 minute, only 1 minute to solve this question. Okay? How about you doing this question right away? Right away. Remember, we are supposed to take the component of velocity of the block along the string. Okay? Along the string, and that should be same for both the points. For this point and also for this point. That is the two ends of the string. They should have the same velocity along the length of the string. Okay. So guys, I need the answers coming in from your end. Yes, Ritu, right? Yes, K, Ritu. You can expect similar questions in NEET as well. Okay. Chalo, let's have a look at this. Let me see the answers coming in, guys. Come on. Okay. Shashank has come up with the answer first. It's 20 by 3, Shashank. Awesome. Good job. You have done a super piece of work. It seems you people have understood this. Okay. By the way, let me go ahead and solve it. Okay. For all of you viewers who are going to watch it later. Okay. But I would say, even if you are watching the recorded video, okay, during that time, pause the video for 2 minutes, solve this question so that you get the confidence that yes, I have learned this particular method, okay, and then go ahead and solve it once again. Fine. Chalo. Here I have 5 meters per second. This is moving. So, along the length of the string, what will be the component of the velocity? See, if this is 37 degree, vertically opposite angle, this will also be 37 degree. So, component of the velocity in this direction will be 5 cos 37 degree. Alright, simple idea. Here, this is velocity VB. Component of this velocity along the direction of the string, will be equal to VB cos 53 degrees. So let me just move ahead. So I can write this will be equal to your VB cos 53 degrees. Simple idea. Okay. Now all I need to do is insert the values into this equation. 5 into cos 37 is 4 by 5. Will be equal to how much? VB into cos 53. Cos 53 is 3 divided by 5. 5 and 5 will cancel, which implies your VB will be 20 divided by 3 meters per second. That is your option A. Concept clear, constraint relations in your string. I hope everybody has understood this particular concept. Now let's move ahead to the next concept. What is it? Your constraint relations in pulleys. Now students, in today's session, I'm going to teach you a very powerful method. Okay, and using that method you can literally solve lots and lots of questions. Okay, say 70 to 80% of the questions that are there in constraint relations in pulleys. Fine enough. But yes, in 20% cases there are going to be some kind of exception. Now we will deal with those exceptions later down the line, but right now let us learn the standard method and I know for sure that when you do this constraint relation, you have been thinking about doing this constraint relation. You have seen we take the length of the strings and then like we say the length of the string is not going to change. We differentiate it with respect to time and we do all kinds of things. And sometimes it becomes very difficult to imagine the entire thing. Right? Sometimes you have been asked, acha, see if this block is going in this direction by X, then how much will the other block be going by? Let's say it is going by Y. Then what is the relation between this X and this particular Y? My goodness, it becomes so difficult to imagine. I used to do it a lot of time when I was in your 11th and 12th standard. And some way I used to just skip this particular part. Okay, it's difficult to imagine. Some question would be like, easy to solve. Other questions would be like, very difficult to manage. Then I think right now we have a method, okay, which can really solve your troubles to a great extent. Okay, so let us look at that method. We have multiple methods, by the way. We have multiple methods. Okay, so let us look at one of the standard methods. All right, we'll take up this as the question for sure, but let me teach you the method first. All right. For this, see, there is a certain derivation, but yeah, there is only limited time in today's session, so I'm not going to go for the derivation right now. I'll right away teach you the concept and we will use the application. We'll use the formula. We'll just try to apply it into multiple numericals. Clear? Acha. Simple idea is, see, one simple case that you have seen is that if you have a pulley, and if you have two blocks, say block A and block B, then we know in this case acceleration of block A is equals to acceleration of block B. Till here life was very simple in Newton's law. We did not have any trouble whatsoever. But life became complicated when this fixed thing was gone. Okay, when this fixed thing was gone and they said, chalo, now let's make the pulley also move. Let's make the pulley also move with a velocity Vp. Okay, and let's say this is moving up with a velocity Va, this is moving with a velocity Vb. Then as per the formula that you're supposed to use, okay, and which is going to make your life, remember this students, it's going to make your life very, very simple. Okay, that is velocity of P will be equal to velocity of A plus velocity of B divided by 2. See, dekhne mein, just have a look at it for the first time. It is a very simple formula. Okay, but let me tell you, it can really solve some very, very complicated problems for sure. Okay, so let us go ahead and apply it into a simple numerical first, and then we will try to upgrade the questions. Fine enough. Everybody has understood this particular question, understood this particular concept out here. देखो concept तो कुछ नहीं है, बस formula. Right? I hope everybody has got this particular formula out here. Okay, so chalo, let's go ahead and solve using this formula out here. Velocity of the pulley is equal to velocity of A plus velocity of B divided by 2. Okay, all righty. Now let's move ahead. So what are they saying? This end is fixed. This pulley is going up with a velocity of how much? 4 meters per second. It is going up with a velocity of 4 meters per second. Find out the velocity of block A. So let's say if block A is moving with a velocity of V, then every point here will also be moving with a velocity of V, but this end is kind of fixed. So every point on this end, I'll say, will have a velocity equal to, let's say V1 is equal to 0. Remember, the end which is kind of fixed will have a velocity equal to 0. Fine enough. Now see this. 4, that is the velocity of the pulley. See, we are using this formula, Vp equals to Va plus Vb divided by 2. Listen to this very carefully now. Vp is equal to how much? 4 is equal to V plus 0 divided by 2, which implies velocity will be equal to 4 into 2, that is 8 meters per second. So option B is the correct answer, right? I hope everybody has got it. I hope everybody has got the concept right now. Okay, chalo, now let's use it into another question, and I will expect all of you to use it. Why not? Isn't it? We have this next question out here. So guys, go ahead, use the concept and find out the answer and write it into your chat box right away. Okay, so I'm giving you 1 minute, just 1 minute, nothing more than that is required for this question now, if you have understood the concept. All right. See guys, if you are liking today's session and you're learning out of it, do not forget to press on the like button and share and subscribe if you're there for the first time, and remember to press on the bell icon. You know why? Because if we have sessions coming up, you should be notified about this particular sessions, isn't it? So that's the reason why do not miss out on any of the lectures on YouTube. Okay, it's free and it is full of rich content. So should we begin? Should we begin solving this problem? Okay, chalo, let's move ahead. Now they are saying that this is a pulley block arrangement system. Block A is moving up with an acceleration of 2 meters per second square. Then what will be the acceleration of block B? What will be the acceleration of block B? Simple idea. Okay, now see, this end is fixed. This end is fixed. So acceleration of this part will be equal to what? 0. Any point we will take it to be equal to 0. Let's say the acceleration of this is equal to A. Then can I write down? Okay, by the way, let me do one thing. Let me put it in the downward direction itself. Okay, so if this is going down with an acceleration of 2 meters per second square, can I write down 2 will be equal to 0 plus A divided by 2, which implies A will be equal to 4 meters per second square. If this is going down, listen to this very carefully. If this is going down with an acceleration of A, this will be moving up with an acceleration of A. Why exactly? Because see here, this pulley is actually fixed. That means velocity of the pulley is equal to 0. That means if one is A, the other one should be equals to minus A divided by 2 in order to give the result as 0. So this pulley is fixed. So this is, if this is down by A, this will be up by the same value A. So what is the value of A? 4 meters per second square. Option B is the correct answer. All right. So guys, I hope everybody gets it. Everybody gets it. In the figure, acceleration of A is given. We are finding out. Acha. So there is a slight mistake here. Acceleration of B. Find out the acceleration of B. Thank you for the correction, by the way. Okay. Chalo guys, let's have a look at the next question. By the way, in this question, let us twist this question a little bit. Okay. How about twisting this question a little bit and then solve it, right? Chalo, let me do one thing. Let me twist it a little bit. Let me erase everything on the screen. How about if this part of the block, let's say we have this pulley here connected to this block here. Then there is another pulley which is kind of fixed. This is also fixed. This is also fixed. Now, instead of this going down, how about, let's say this block is out here on a surface and it is making an angle of 37 degrees. Okay. Same thing, this is going down with 2 meters per second square. Then find out the acceleration of block B. Okay, not the velocity but the acceleration. So we'll take here the acceleration of block B. This is what you're supposed to find out. Okay, guys, let it be a homework for all of you. Simple idea is that we need to club in both the concepts that we have learned so far. The concept of string constraints, that is both the ends are supposed to have the component of the velocity along the direction of the string should be equal, and the concept that we have learned just now. Club both of them and you will be able to find out the answer to this particular question. Okay, so this, let it be your homework, and you can write to me on the comment section. You can write to me on the comment section, and if you get it right, I'm definitely going to mention your name in the next class for sure. Okay, chalo guys, now let's move ahead to the next question and let's see how to do this one. Okay, we are going to use the same method. We are going to use the same method for this question as well. I hope you're finding these things to be very comfortable right now. The constraint relation, which is generally a headache for the students, I think now you are able to get hold of this particular concept, isn't it? Chalo, let's see this particular thing now. We've got two blocks, block B and block A. Block A and block B. Block A is moving towards this direction with a velocity of how much? 10 meters per second. Block A is moving in this direction with a velocity of 10 meters per second. Then what should be the velocity of block B? What should be the velocity of block B? How are we supposed to do this question? Do you want to attempt it? Do you want to attempt it? Chalo guys, let's move ahead. How do we do this question? Let's see the answers on the chat box coming up. Let's see the answers coming up on the chat box. Sayansh, Ayush, I think if there is time left, we will go ahead and do that question as well. Okay, but let's see if anybody gives me an answer to this one. Think about it. Think about it. Okay, pause your screen for some time. Pause your screen for some time. And then, acha, by the way, it's a live session. I was thinking about the students later down the line, so they can pause the screen for some time and think about it, how to do it. Okay, I need a single answer coming up. Come on guys. All right, I think you're taking more than a lot of time, so let's try to understand it in a very simplified manner. Okay, if this block is going in this direction with 10 meters per second, koi dikkat nahi. If you have not understood, we will spend some more time out here. Okay, simple. This block is going with 10 meters per second. That means this point here will also be going with how much? 10 meters per second. See, this pulley is attached to it, so this will also be going with how much? 10 meters per second. Clear hai ye? This is going with 10, this is going with 10. This pulley is moving ahead with how much? VB. Alright. Every point on this string will be moving ahead with the same velocity. Acha, by the way, this, let's say, is moving with a velocity V. And this string is fixed. So, iski velocity kitni ho jayegi? 0. This will have a velocity of how much? 0. Simple idea. Okay. Now, how many unknowns are there? How many unknowns are there into this particular question? VB and V. How many movable pulleys are there? Number 1, number 2. We can write down two equations for two pulleys, that is VP equals to VA plus VB divided by 2. So when we write down two equations and we have two unknowns, we can definitely get what is the answer, right? So chalo, let's have a look at it. Simple thing, we'll write it for this one first. So VB will be equal to V plus 10 divided by 2. That's the first equation. And the second equation for this, that is 10 will be equals to V plus 0 divided by 2. Second equation. Now from the second equation I can get V is equal to 20 meters per second. Insert the value here. You will get VB is equal to 20 plus 10, that is 30 divided by 2, that is going to be 15 meters per second. Okay. All right. So, excuse me, I think something went wrong. Okay. So, this is going to be equal to 15 meters per second. Did everybody understand this method right now? Did everybody understand this method right now? Yes, I am sure. And if you have liked it, do not forget to press on the like, comment, subscribe. Okay, chalo now let's move on to the next question. Okay, so guys, I'm sure you're having a lot of fun. You must have seen that your questions on Newton's law, they appear to be so simple, isn't it? If you've learned this powerful method, right? Now we have this question. Now here in this question, the method that I have taught you would somehow fail. It's not going to work out. All right, but then we have a different method to do this question, and it is a very simple method. All right, we just need to do tension distribution in this case, the distribution of the tension in the different strings. Say, let's say if this string, let me just go back, go forward. Just a second. Just a second. Okay, so here we are with our pen. Okay, so any answers coming up from you guys? Any answers? See, that virtual work method is always there. That is, we take t dot x equals to 0, summation of t dot x equals to 0, or summation of t dot a. I am sure a lot of you have already learned this method. This is there, so common in all the books now. Okay, if you know this method, it's fine. If you know this method, it's fine. Okay, this also really saves a lot of time and helps you to visualize a lot of questions. Okay, but in certain questions, this also fails. All right, like that's what the beauty of Newton's law. Like that other method I taught you, it would fail out here. Okay, so let me teach you what do we do in such case. We don't have much of an option. We need to keep our eyes open. I told you already, 70 to 80% of the problems you will find it pretty comfortable. There is going to be no tension at all. You can easily apply that and sail through your journey. Okay, but when you have questions like this, okay, if the first method doesn't work out, do tension distribution. That should be coming to your mind first. Okay, if the method that I taught you does not work out for any reason whatsoever, let's say, all right, and you are getting stuck up and not able to figure out what should be the answer, next thing you do is tension distribution. Okay, so if this is tension T, this will be T, this will also be T, this will be equal to 2T. If this is T, this will be equal to T. All right, now under such a circumstance, if you look at this particular pulley out here, if you look at this pulley here, there is an unbalanced load. Okay, there is T here and 2T in the bottom. First thing, this should have a mass, so that if it has some kind of an acceleration, it must have a mass. But let's say if it is an ideal pulley, then under those circumstances, T should be equal to 0. T should be equal to 0. Problem solved. Okay, even easier, right? You don't have to think much about anything other than T is equal to 0 in this case. Okay, so what you can do, you can write down the equation for block A. Block A, if you write down the equation, it will be T minus M1 into G will be equals to M1 A1. And if you look at this, let's say it is going down, then I can write down M2, or let's say write the same equation here as well. Write down the same equation here as well. That is tension, okay, minus M2G. See, we are assuming that, let's say it's going down, so I'll have this is minus, and let's say this is kind of moving up, then I'll have tension minus M2G as equal to M2A2. All right, simple equations. Now tension has become equal to 0. That means A1 will be equal to how much? If you put tension as equal to 0 here, A1 will be equal to G and A2 will be equal to how much? Minus G. Simple. Option A would be the correct answer. Fine. So in case your method fails, you just go ahead with the tension distribution. You will get some kind of a clue to move ahead with the question. All right, chalo. Now using the same method that I have actually taught you, all right, let us look at these questions, right, wherein you need to find out the acceleration of the block of 2m. Clear? Now how do we go about it? It's very simple. Now it's become like very simple. All right, we need to know the relation between the acceleration of m and that of 2m, right? Let's say if this is going down with an acceleration of a, then every point here will be having the same acceleration. Similarly, these points will also be having the same value of acceleration, right? This is connected to a fixed support here. It is connected to a fixed support here. Then acceleration of all the points here will be 0. This will be equal to a. Let's say this is having an acceleration of a1. This is having an acceleration of a1. Now here all these points will be moving in this direction, right? So using the same relation that I have taught you, that is a1 will be equals to a plus 0 divided by 2, right? So I can write down my a1 will be equals to a divided by 2. Clear? Simple idea. Now what can I write my a as? What can I write my a as? See here, there tension will be T, here also tension T, here also tension T. Now I can write down the equation here. See this, very simple. What is the equation? Simple idea. If it is going down, I can write here m into g minus t is equal to m into a. And for this, I can write down total tension here will be equals to 2t. So 2t will be equals to twice m into acceleration a1. a1 is equal to a divided by 2. 2 and 2 cancel, right? Multiply this by 2. Multiply this by 2 throughout and add it up. Add it up, 2t will get cancelled. What are you going to get? 2mg is equal to 3ma. 3ma. M and m cancel. You will get acceleration as equal to 2g divided by 3. So this will be the value of your acceleration. All right. Then we need to find out the acceleration of 2m. Acceleration of 2m is equals to how much? a1. a1 is equal to how much? A divided by 2. So this will be equal to g divided by 3. Option C is the correct answer. All right. So guys, this I have covered a lot of questions. All right. I mean, the concept that I have taught you will sail you through a lot of questions. All right. Now, since time is also limited on this particular channel out here, we will be able to do only the most important concepts. All right. Now, since I have given to you the mantra or the key to a lot of questions, so go ahead and solve this question. It will also be very simple. Let me tell you. So this, let's say, is your homework. You can put down the answers on the comment box. All right. Even if you look at this question, this will also be very simple. Use it. Use the constraint relation out there. Go ahead, write down the equation for this block, you will get your answer. It's not a very difficult question. All right. Last thing which I wanted to tell you was that in your wedge constraint, there is a simple concept that you must know, that now this can move in this direction, but this is constrained to move only up and down, right? Then there is a simple rule that you need to know, that is, if you draw a common normal out here, just a second, if you draw a common normal out here, what happened? Okay, if you draw a common normal out here, then remember one thing, that is, this point of this particular inclined plane will be moving in this direction with 3 meters per second square, and we need to find out the acceleration of this block B. Acceleration of block B. Then the concept is, that is, you must remember this, that is the component of this acceleration along the common normal. Okay, so what will be the component of 3 along this common normal? It will be 3 times, understand, if this is theta angle, this will be theta, this will be 90 minus theta, this will be equal to theta. So 3 sine theta will be equal to, what will be the component of AB along the common normal? AB cos theta. Simple idea. So AB will be equal to 3 tan theta. Now you put down the value, whatever is the value of your theta, you will get your answer. All right. So students, this was the main concept of your wedge constraints, and you can go ahead, use it into this particular question as well. Okay, let it be one of your practice questions, and that's it from me for today's session, guys. Most importantly, besides these concepts, you must not forget something really important. Yes, JEE Unacademy is a huge family now. All right, family of the great educators and you students, all right, who are a part of this big revolution that is happening. Okay, and yes, on our Instagram page, we keep coming up with a lot of updates of what we are doing, what we are planning out. Okay, and we are doing super things. I mean, you might not even imagine what are we going to come up with in the coming months. All right, it's going to be like huge big platform to give the best to you guys. All right, and you must have understood the passion, you must have seen it, it's live right in front of you, the passion with which the teachers, they prepare their sessions and bring up the best for you on the YouTube channel, on the Plus platform, and everything that we get a chance to interact with. And when it comes to interaction, how can we forget? We want to receive as many messages as possible from you people, because let me tell you, simple idea, once we prepare these lectures, it cannot happen in silo, it cannot happen just sitting down in a room out here. It has to be through an interaction process, right? So this Telegram app and the URL here will help you to reach out to us and tell us what exactly it is that you people want. Okay, now based on your messages, your comments, your understanding of what is required for you, okay, we are going to prepare and come up with the next sessions. Like, I had decided something totally different for Newton's law, but when I saw the messages pouring in that, sir, this is our pain point, spring is our pain point, constraint relation is our pain point, I prepared the lectures right on those topics itself. Okay, so guys, remember, subscription is important. Also, after we are connected to each other, we would want to connect with you on a long term plan. Okay, now for that, Unacademy subscription, we have the live classes. You can get to chat with the educator, and it is a super experience. If you haven't done it so far, let me tell you, if you haven't done it so far, come over to the platform and learn on the Plus platform. You will know the difference. You will know the difference when you can actually chat with the educator, when you can actually get to interact with him on a regular basis, right? All of your doubts and concepts are just simply going to evaporate. All right. So guys, not just that, we we have those interactive polls which keeps on happening on every question. Students don't feel as if they're not a part of the session. Okay, it's not like one of those offline classes where the teacher goes on and on and on, and then finally you have the bell rung, or let's say the class ends, and you are happy chatting with your friends and learning is totally not taken care of. Okay, so here we have the interactive polls, so that little questions, those little questions in the interactive polls, they create so much of a difference in the dynamics of the class. All right, so guys, test series and analysis, another very important part of your preparation, and most importantly, who can neglect this point? Who can neglect this point? Live doubt clearing sessions. Okay, guys, this is the essence. This is the essence of the entire live interaction. Okay, that is, you get a doubt then and there itself. Maybe you are doing the topic in the class on the Plus platform. Okay, and then suddenly you remember that in the class, in your school or in your coaching institute, there was a certain question which you were not able to solve, and you have been struggling a lot with this question for some time now. Okay, go ahead, click a photograph. All right, put it right then and there itself. There is no limitation of these are the only number of doubts I can ask in a platform. So you can go ahead, ask as many number of questions as possible. Okay. And students, most importantly, with one single subscription, okay, you get an access to so many top educators of the company. Come visit the platform, you will get to know who are the educators out here. They are preparing and giving in their best so that you can benefit out of these sessions. Okay, it's a superb platform, let me tell you. I mean, Unacademy has planned out something which is a revolution in this country for sure. Okay. So guys, if you haven't installed it so far, search for Unacademy learning app. Once you get it, which I'm sure is very easy. This is like, you guys are the new generation kids, man. I mean, like, I don't need to tell you all these things. Okay, but still, let me go ahead. Install it right away. You will get, if you have a good subscription of internet, it will be downloaded like very soon. Okay, and once that is done, 3 important steps I'm going to tell you. Plus, go in for the plus, then choose for IIT JEE and click on the get subscription button. Once you have done it, now I'm going to give you a happy news. What is the happy news? That use the code SMLIVE, and right away you will be getting a discount of 10% right then and there itself. Okay. And students, remember, very importantly, this is a very important point. Okay, first of all, whatever I taught you, you will get it into a PDF format. Okay, you can download it right away. Second thing, if you haven't subscribed to the channel, do it right away. And press on the bell icon. Why should you press on the bell icon? So that any lecture which is coming up, now there is going to be like this year onwards, okay, JEE English channel will have courses only in English been coming up. Okay, like we had the last year's channel JEE. Okay, so Unacademy JEE channel where there were lectures in Hindi, but this year onwards you will have all the courses in English. So press on the bell icon. Do not forget to press on the bell icon. So otherwise you will not be notified if we have some really important lectures coming up. Okay, so do not forget to do that. And yes, besides this channel, this is not the only channel. We have the NEET channel, the JEE channel, the foundation channel. So if you have any of your friends, your neighbors, your others, colleagues of your father or mother, and they are planning to prepare, you know, at whatever level they may be, we are trying to give our best to each and every section. Okay, so you can go ahead and do it. And lastly, SMLIVE to get a right away 10% discount. So guys, I hope you enjoyed today's session and you had a lot of fun. So there are some questions. I'm going to read out the questions to you. Okay, just a second. Should I buy Cengage if I join Plus? Are questions in... See guys, let me tell you what happens is that a lot of you students have a query ke yaar Unacademy mein jo ho gaya wo, I mean, like, you know, is that enough or do I need to do more? Students, I passed out in 2007. I started teaching in 2010 onwards. It is 2020 right now. See, there is no end to the number of questions, and sometimes even I see a question and I would find ke are yaar karte hain isko. I have seen this kind of a question for the first time. So it's been 10 years now. So how do you expect that it would be enough for any particular thing? But I can say the subscription, because we teachers have been, like, you know, we have been having the experience, right? Okay, what exactly is the recipe for success for you guys, right? So I know exactly that these are the things. I know that spring is a pain area. I know constraint relation is a pain area. And similarly, all the pain areas that students generally have in physics. So it is not just about a book, right? It is about the faith in the teacher. If you know that today's session where you have learned so many beautiful problems, okay, you know that yes, I will come here, I will get benefited. That is the faith that you require in your mind. And I know after today's session, okay, you are sure that whenever I log into the channel and see Sumit's lecture, it is going to create a difference in my life, right? So that is the faith that I am looking forward from you guys. So God bless you all and see you tomorrow with more. But tomorrow's session is going to be on your work energy theorem. Now, work power energy, there are a lot of concepts, but mostly your work energy theorem is again one pain area for the students. And lot of questions get solved using the work energy theorem. So tomorrow we are going to look at your work energy theorem. So guys, now time for your mathematics. Bye bye and see you.